Good day for everyone. Thank you so much for seeing this presentation. We are the group number 8, and we're talking about the chlorination process in water purification plant. We stay in the step number 4 in the DMAIC methodology, improve. With the content, we have the company background. The product of this company is the drinking water. This is the activities, but we're concentrating in the chlorination process and the location of this plant in Guayaquil. This is a supply chain, and the principal customers is the water consumers, but other departments in the company. In the project team, we have the PhD Clever Barcia is the project advisor, and the project analyzes Sonia Argudo, Fátima Ponce, Bryan del Pezo, and my person Samantha Petroche. Continues with the problem focus we have in the Guayaquil water purification plant has increased in 6% in the average of product out of specification in the shift number 3, when the company standards is at 2%. In the objective focused, we have decreased the percent of product out of specification in the residual chlorine from 6% to 4% in the shift number 3 in 4 months. Or G is in this case the percent of product out of a specification in the chlorination process. We use this equation for determining.
Regarding the current situation of the simulation, there was a version in which only fluid elements were available in hexene, but due to the complication they wrote, we were recommended by Dr. Barcia and the engineering program to make fluids to a certain point and convert it to objects and they continue with the other machines. This was a current situation simulation. In this case of verification, the two versions we presented to the engineer Yoshiro, getting the go-ahead from him there. Therefore, we have already worked directly to find results with respect to the original. The distribution in this case will be mixed chlorination chambers, type combine this empirical distribution, and the process inspection, the normal distribution. For the validation simulation, the original results, 38 bags of the 1 kilogram of those chlorine from 13.7 boxes and the one the way with the conveyor with the 40 bottle of the treated water of 500 liters each. Of the 32 boxes came out in good condition, while 5 boxes were out of specification. This is our model. For kinds of the experimenter, we take the value of the inflow and outflow rates of the untreated water, as well as the rate at which the passes through the pipeline and the entry rates of the bottle. The inspection machine processor with the minimum and maximum in which the mix state around 30 minutes, and the number of objects in the transport that from scenario 1 to 5, from 6 to 10, it is with serial. He had following for us. This one is the indicators and spread around your results. This one, we have the best option will be X4, X5, and X9 and X10 because they have fewer products on call. This one waiting line. On the other hand, the output, this one products main. On the other hand, because they are still the smallest, so it should be considered, let's say, that is cost and benefits with respect to the higher throughput it has. And the rest of good conditions and all specification following correlation to inspection products made because they are only resale depending on the percentage. And so with all these, the percentage, the following solution proposal can be made.
Now we are going to present the proposed solution for each of the root causes. For example, the third root cause is that the dosing machine is far from the operating area. One solution can be make a collection of chlorination activities and generate standardized operational procedures. Another solution can be generate a system that connects the dosing machine with the operator's place and that shows on the screen what is dosed and what is in the tank. And the last one solution can be establish a clear communication methodology and periodic evaluations. Now, for the solution analysis, we did an economic analysis, where estimate the cost of each of the solutions, considering the assets, workforce, capacitation costs, and additional costs. We also did a final analysis, consider if the cost, impact, and effort was bad, not good, good, very good, or excellent. And the result was the solution 1 and 2 were those with a high final value. So the solution that we selected was the process standardization and dosing system, which are the ones that have a high impact and require less effort, as we can see in our impact and effort matrix.
Then we have implementation plan. We have the two root cause with the two previously selected solutions, with the 5W cost and the state of each one. In the case of the first solution, it's with respect to the distance between the operator and the machine. Next, we have the schedule implementation. We have the tasks name, duration, start, end, responsible, all day of month, January 2022. This is for the first solution. This is for the second solution. Make a collection of chlorination activities and generate standardized operational procedures. Then we can see client participation evidence. The next step, we have the control for this project. Control the process, validate projects, benefits. Thank you.